So I'm Dennis Dalessandro from Intel. I'm going to talk to you guys about the exciting world of driver development. You've probably seen my name about 1,000 times if you follow the Linux RDMA mailing list. And what I'm going to talk to you about is a large part of that. This is work that we did to remove a lot of the code duplication between some of our drivers. So the three things that I'm going to cover are: what is this RDMAVT thing? Why did we want to bother with it? A little bit of the technical aspects of things, and also how do we actually get this into the kernel, because it wasn't an easy road. So the reason we're doing this is pretty simple: code duplication. So we could stop there, but we'll expand on it a little bit. Basically, we had three drivers: the iPath, QIB, and HFI1, and they're very different hardware, but they're all built around the same software implementation for verbs. And when we posted HFI1 on the mailing list, we were called out for this, and it's something that we decided to address now. So they do share the same IBTA construct, these Q-pair, protection domain, completion schema. All this stuff is the same in all these drivers. The differences are what actually happens under the covers to put the packets on the hardware. Obviously, the big problems with this are the maintenance for the code. So bugs in any of the drivers is a bug in all the drivers. And this happened, it would happen again. I've personally fixed bugs like this in multiple drivers. The same goes for improvements, whether they're performance or new feature, whatever you put in one, we've got to do to all of them, or could do to all of them, and not necessarily going to happen because older products don't have the same priorities all the time. So there could also be other things in the future, other software stacks or drivers or hardware, whatever that would want to have a software verbs implementation. So it would be good to have a unified place for all this stuff to live. And I do want to note that while there was 3 copies of everything, we did get rid of the iPath driver, so we're left with 2. So we fixed 33% of the problem right there. But the real solution is this thing that we called RDMAVT, and it was spawned out of the discussions on the Linux RDMA email list when we submitted HFI1. It stands for the RDMA Verbs Transport Library. I know some people don't like the transport in the name or whatever, but that's kind of the name that we had and stuck with. So that's what it is. It's basically a new kernel module that lives in the InfiniBand tree, and it implements the verbs in software. So it's got all those IBTA good things, the Q-pair, protection, that stuff, that's all implemented inside of RDMAVT now. And it's going to use the drivers like QIB and HFI1 to actually put the packets onto the wire. The goals, the most obvious goal is clearly to get rid of the code duplication, but there's a caveat to that. These aren't your garden variety network devices. These are high performance interconnects, and performance is the most important thing. So there's times where we might not have the most perfect implementation from a design standpoint, good software engineering, but the performance matters the most. We also cannot cause regressions, since QIB it's been there for years, 10 years or something like that, I don't know. And it's stable, so the last thing we want to do is cause disruptions in that. We also want to be able to support multiple hardware devices. Right now, there's the only 2 drivers that it deals with are Intel drivers, but there's no reason that it can't support any other number of things that come down the pipe later. So that doesn't mean we're actually going to do the work to support these other things, but we don't want to do anything that would make it unduly hard for somebody else to do that. Incremental development is also an important aspect. We're not designing a core kernel API here that is going to be used by tons and tons of drivers. This is something that's used by a couple things in the RDMAVT or RDMA tree. So we just need to get it done, make it work, and we're going to improve this as we go. Iterative development is very important here. It's also not something we're just going to throw out there and be done with. It's something that's going to continue to be improved and worked on as time goes by. Development in the open, this is also an important aspect to me especially. So we announced it on the Linux RDMA list, and we said this is what we're going to do, and we started posting the code to GitHub very early. So way before we even posted it for the first time on Linux RDMA, it was posted on GitHub. And so the idea was that the few people who are actually really interested in this stuff, they could go there early and see the code and provide feedback, and they could even grab it and use it if they want to. So I don't know how good you can see this picture. I'm a developer. I write C code. I don't make PowerPoint slides. But this on the left there, the then is before RDMAVT. So you've got those orangish brownish boxes there. Those are the applications, and then we've got the IB core verbs is that blue blob, and then we've got the two drivers underneath that, QAB and HFI1, and the drivers are divided into three things here. We've got verbs, the protocol code, and then the underlying driver code that actually does all the hardware goodness. When we have the RDMAVT model, which is on the right, the verbs component of the drivers goes away, and we got that big green block. Now we still have the protocol code and the driver code, and the reason that we still have the protocol code, I'll touch on that here in a slide or two. So what does RDMAVT actually provide? It handles the driver registration, so drivers aren't registering with the IB core anymore, they're registering with RDMAVT. It has, obviously it's got those IBTA data structures I keep talking about, the Q pairs and protection domains, MEMRs, CQs, SRQ, et cetera, et cetera. The data structures as well as the functionality, all that stuff is in RDMAVT. Almost all of the verbs functions that are in QIB and HFI1 have been moved to RDMAVT. There are some exceptions, and I got that on a slide here in a second. RDMAVT also has this notion of driver override. So this is an important concept. The RDMAVT is not in charge of what it does or what it implements for verbs. It's the underlying driver. So while RDMAVT may support all these different verbs calls, the driver may decide that it wants to control its own destiny for posting sends or registering memory or whatever. So RDMAVT provides the ability for drivers to override and decide what it wants to do. There's also notion of private data structures for things, because RDMAVT needs to provide a place for the drivers to hang their specific stuff. So an example of this is in the Q pair, we have this big private blob that is, as far as RDMA is concerned, is just a pointer to somewhere. There's also calls from RDMAVT into the driver, and vice versa. There's calls from the driver into RDMAVT. And we want it mostly to be, we want RDMAVT to do most of the work calling into the driver. So the drivers will do the hardware stuff on behalf of RDMAVT. We want to limit the number of things that the driver needs to call an RDMAVT for, but there are some. Just as important of what it does do is what it does not do. We're not going to move and incorporate code that is going to take just the same amount of code to make generic and abstract the differences away as it does to just leave the little bit of code duplication there. So an example of this is the modify device. There would be more callbacks into the driver, and we would end up with more code than just leaving it. So why bother? The MAD processing is another one. The MAD layer is very different between QAB and HFI1. Now, there's probably some abstraction that we can do there, but it's going to require more investigation and thought. We changed a lot for this first round, so I think it's good to let things settle out and let RDMAVT soak for a release or two. RDMAVT doesn't address the protocol code duplication. This is when it needs to send an ACK or whatever. While the code is very similar between the drivers at the high level, there are hardware nuances and things in there that are very important to performance, and mucking with this code is very risky. The bottom line is performance is the #1 priority. So if we're going to try to deal with this, it's going to be follow-on work, and we need to look at it still. RDMAVT is also not a replacement for the IB core. The drivers still need to know that it exists. We want to try to limit it as much as we can, but there are things that IB core provides that RDMAVT needs as well, and why would we bother to reinvent the wheel for that? So one example of that is with the device registration. So drivers still fill in this struct IB device and pass it to RDMAVT. Basically, everything that's in there is what RDMAVT is going to need anyway. The whole notion of the driver override stuff that I mentioned before, that's driven by what's in this IB device structure. So basically, it's pretty simple. If the function pointers are set to null, then RDMAVT is going to go ahead and provide that functionality for the driver. And in that case, there is also, like I said, there's a number of things that the RDMAVT needs to call into the driver to have done on its behalf. So the checks for those required functionality is going to be done at this time as well. Now, if the driver decides that, hey, I want to do my own Q pair creation or whatever, and it puts its own function address in there, then there's no dependency checking involved there. RDMAVT is going to go along and it's going to do some more initialization, locks and worker threads, whatever, and eventually it's going to call the IB register device on behalf of the driver. So there's way too many functions to go through in the time that I have here, and it would put everybody to sleep as well. So I'll just say that there's three ways that verbs calls work. So at the top here, we've got the IB core calls into RDMAVT, and RDMAVT needs a driver to do some stuff. So he's going to call in there those functions that I keep talking about. The prereqs are checked beforehand. And it's going to use a driver. The other is, in the middle there, is things that RDMAVT doesn't need the driver for at all. Like protection domain, it's a completely software thing. It lives in RDMAVT, so the driver's not involved. But then there's things like the process MAD, where the IB core is just going to call whatever the function pointer is. It's going to completely bypass RDMAVT, and it doesn't know the difference. The other thing that this bypass, the override, whatever we want to call it, offered us was we were able to, from the very first patch series of RDMAVT, have a completely working driver. So it just happens to be that all the function calls are being redirected right into the existing driver where they were before. So that whole iterative development thing. Now, I do want to mention a couple things about the data path here. The posting of the send, it was basically a complete copy and paste between QIB and HFI, and there is an argument to be made that this is really Intel specific, or those two drivers specific. So it's possible that could be a candidate that we may want to move out of RDMAVT and put it back into the drivers. But at the same time, if something else comes along that wants to use RDMAVT, it's got the option to provide its own post send or whatever. On the incoming side, that's completely down in the hardware, except for the posting the receive, which is kind of different. But basically, the driver is it's gonna handle using RDMAVT. So this is one of those instances where the drivers need to call into RDMAVT, and that's where it's going to give it the completion queue event. So it's going to do that for the sending and receiving. And like I said before, the driver handles the protocol work, whether it's going to send an ACK or whatever. So, like I said, this is in the kernel, and getting it there wasn't necessarily easy. And how we did it was we developed this thing completely in the open, right? Like I said, we posted it on GitHub. We went right into writing the code because we wanted to make it work. We even had other vendors submit patches really early on, and those got submitted and ended up in the final release. We used GitHub to make the code available early, but because of some of the other challenges, this was also a really important thing to have. Due to the sheer number of patches, it also gave us a good place to show the ordering. We had hundreds of patches spread over months that were rebased and commented on and resubmitted, so it was a giant tangled mess for the maintainer to deal with, I'm sure. We also had it set up with 0-day builds, and we did find things. So those were fixed before they even got pushed onto Linux RDMA. The other thing that's sort of different about the way we did RDMAVT versus the way we did HFI is the we didn't submit just a final version. So with HFI, you know, it was all developed in-house, and when it comes time to open source, we break the driver up into chunks and we submitted it. With RDMAVT, we have all the dirty laundry is there in the Git log. So from the very first patch to the very last thing. And I think that's kind of an important thing to have for projects like this. So some of the challenges that we had here stem from the fact that while RDMAVT and HFI are new drivers, QIB is not. QIB is a stable driver, and QIB lives in the InfiniBand tree. The HFI1 driver, mainly because of the code duplication, the need to do RDMAVT, ended up landing in staging. Now, these are two different trees. They're maintained by two different maintainers. So it's kind of hard to submit patches to one when they depend on the other. So that's one of the main reasons why we use GitHub as well. So we have one place for all this stuff to land. There was an agreement made that the Linux RDMA maintainer would take over the staging RDMA subtree for 4.5. And that mostly happened, which let us start to actually get our patches going out. There are still patches that were sent to the staging list, and it caused some minor headaches. In fact, I think there's still one last week as well. We'll deal with that. The other thing, we had to make sure that we had RDMAVT ready, completed by the start of the 4.6 merge window. And this is, it's not just RDMAVT here, it's HFI and QIB as well. So just because I'm working on RDMAVT, we have a team of people working on HFI1, so there's still things that are being developed, features going in that need to go out. So there was a tremendous effort for a lot of people involved. It's over 300 patches, it's probably closer to 350 patches that we submitted for all three of these drivers. So the RDMAVT, QIB, and HFI1. So there's changes to rip the guts of the verbs out of QIB and HFI1, but there's also a number of style and bug fixes and new content for HFI1. Because like I said, the rest of the driver team doesn't stop in development while we work on the verb stuff. All that stuff that went into staging as well, there were some patches that got pulled into staging, but there were some that got left over. They're kind of left out in limbo, so we had to submit those as well for 4.6. And so like I said, this is a lot of work by a lot of people. I post the patches, but there's a ton of people that develop this stuff, and I guess I could have put a slide here with a ton of names on it, but I invite you to just go look at the Git log for those two trees and see all the people that worked on this stuff. There was obviously a number of contentious threads on the email list, and those that follow it, I'm sure you know what I'm talking about. We don't really need to go open up those cans of worms here, but if anybody wants to revisit any of that stuff, come find me afterwards and we'll talk. In the end result, this is accepted, and it's in Linus's tree for 4.6. So what's up next? We need to look at the protocol work. Is it actually feasible given our performance requirements? Are we going to be able to do this? Another thing is there's other duplicated code in these drivers. We have this Twizy stuff, this two-wire serial interface stuff that is it's virtually identical, but it's not really verbs related. So where do we put that? So we need to find a place for. Apparently, he's got an idea. So we need to address that, and we also recognize that RDMAVT is going to continue to evolve. It's not done. Like I said, it's not a fire and forget thing. We're going to continue to maintain it and work with people that want to use it and incorporate their own stuff in it as well. And our favorite Intel legal disclaimers and optimization notice. That's it.
I have one question. So I'm a little confused. So you mentioned that it was in 4.6, but it's still in the staging tree. When would it be moved to the the InfiniBand drivers hardware directory with all the rest of it?
So there's another issue that came up where not related to this. There's our PSM interface. We have a write and a write V interface.
Yeah, I saw that on the list.
Initially, the decision was made that it's a PSM thing. It's a private interface. Do whatever the heck we want. If something changes in VFS layer and we break, we deal with it. We thought that issue was put to rest, but Alvaro came back and had a comment, and Linus was brought into it. And when Alvaro and Linus want something done, we don't have any choice. So we got to go back and address that write V stuff now to be able to move out of staging. So I actually submitted the patch to move us out of staging, and we were going to do it, but then we had to pull that back. So
Okay, so so then like in 4.7, it would be moved from
4.7. I mean, we're working on it now. I don't know that it's something that we could actually get into an RC release. I was working on it up until I came out here to give this talk. So
Right.
that's on my top of my priority list right now.
Okay. Good.
Good. Thanks.